Hello, in this session we will evaluate the oxide of sulfur, namely sulfur dioxide and sulfur trioxide. Now, sulfur dioxide is also referred to as sulfur oxide. This gas is colorless, it has a characteristic choking smell, it is denser than air, it is soluble in water, and it is acidic. It does not support combustion, and the unique property is that of its characteristic choking smell. Now, to test for this gas, we use brown paper, in the sense that when paper is oxidized, its color changes into brown. Mainly at the industry, paper pulp, when oxidized, turns into brown. However, sulfur dioxide, when placed into contact with the brown paper, it has a bleaching property, in the sense that sulfur dioxide dissolves in water, forming sulfurous acid, and the sulfurous acid forms the sulfide ions, which are the bleaching agents. The bleaching agents in this case will remove color of the brown paper and makes it white by the process of reduction. Remember, sulfide is a deficient form of sulfate, and therefore it has a high affinity towards oxygen, and when it meets brown paper, it decolorizes it, making it white or bleached. Now, to prepare sulfur dioxide, we need any metal sulfide and oxygen. So the combustion of a metal sulfide with oxygen will form a metal oxide and sulfur dioxide. The applications of the sulfur dioxide is mainly to manufacture bleaching agents in form of sulfite, and in the industrial manufacture of sulfuric 6 acid, otherwise known as the contact process. Now, it is toxic and readily usable as a fumigant. What about sulfur trioxide? Sulfur trioxide is sulfur 6 oxide. This is a colorless gas. It has identical properties to sulfur dioxide, in the sense that it is colorless and it has an unpleasant choking smell. The difference is just the unpleasancy of the choking smell. It is denser than air, it is soluble in water, it's acidic, and does not support combustion. To test it, we conduct a direct synthesis in water, where it forms misty sulfuric acid or sulfuric acid in gaseous state. Now, to prepare this gas, we simply use sulfur dioxide and oxidize it in excess supply of oxygen or air, and readily it forms the required gas, sulfur trioxide. The reaction is reversible and similar to what is done in the contact process, so it's precipitated at optimum conditions, where vanadium pentoxide becomes a catalyst. The pressure is between 2 to 3 atmospheres, and the temperature fixed at around 450 degrees Celsius. The application is mainly in the contact process for the large-scale manufacture of sulfuric 6 acid. Now, this has been a description of the main oxides of sulfur, namely sulfur 4 oxide, also known as sulfur dioxide, and sulfur 6 oxide, also known as sulfur trioxide. We have said that they have identical properties, with the unique property being the characteristic choking smell. While sulfur dioxide has a characteristic choking smell, sulfur trioxide has an unpleasant choking smell. Both gases are colorless, they are both dense than air, they are both soluble in water, the difference being that sulfur dioxide dissolves in water, forming sulfurous acid or sulfuric 4 acid, while sulfur trioxide dissolves in water, forming sulfuric 6 acid or the common sulfuric acid. Now, both of them do not support combustion, so they will extinguish a burning splint. In that case, both of them are acidic, because when they dissolve in water, they form acidic solutions. And we have concluded that their main application is the large-scale manufacture of sulfuric 6 acid. And then they have bleaching properties, and they can be used as fumigants to kill bacteria, and also they can be used to manufacture germicides and pesticides. So all these are fumigants, germicides, pesticides, and insecticides. Thank you very much. That has been a description of the oxides of sulfur.